Good day, everyone. Today, we are doing our final lesson in Algebra 2. This is all about regression. All right, our objective is to create regression equations from most parent functions. And we know when it comes to equations, when we apply them to real life situations, we call them models. All right, just remember this numbers are so powerful that they define you, such as your social security number, your date of birth, and your credit score, the number of times you've been in juvie, all those things. They can also help you survive. With a decent credit score, you get better things. With more money, you could do better things. But they also can hinder you, depending on how many bad things you've done. They can also be used as a weapon, and it's worse than rumors. You know, when you talking about a person's appearance, that's one thing, but when someone talk about your grades, then that's another. When you say, "Oh, you so dumb, you got a single digit grade in Mr. Howard's class," that's brutal. I rather you call me ugly than talk about my grades, cause beauty is behold is wherever they saying goes. Beauty is based on the beholder, whoever looks at it. So I may not be nice looking to you, but to other people I may be nice looking to them, and vice versa. All right, remember this definition. Now, admittedly, your next math teacher will not discuss this. And for those who are going into statistics, you will have it so down pat that you won't even need to have for me to keep posting it. But remember, the precise definition of mathematics is the techniques to explain, understand, and deal with reality by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. So that's the definition I'm trying to, you know, get you guys to understand about how mathematics works. All right? At least we rarely cipher, but that's part of the mathematical life, you know. But everything else we do. All right, announcements. Remember, you are responsible for the assignments posted in Google Classroom only because those assignments are posted in advance. So if I posted assignments like I did last week on Sunday and you was absent on Wednesday, but you was here Monday, the day after I posted all those assignments, well, guess what? You were responsible for it. I told you guys in the beginning that you are responsible for Google Classroom because the guard rule of my class was for you to stay ready so you don't have to get ready. And the truth of the matter is, most of you are not ready. So this may go be turned out to become a problem. Assignments, again, are posted in advance, so you have to get it done. Absolutely not. There's no, Miss Howard, can't get my makeup work. No, because everything is posted. You know, closed mouths don't get fed. If you don't talk to me about things, I can't help you. Like for example, if you can't talk to me about why you absent, I'm not gonna give you no makeup work. And if you heard the principal of Struma, the principal told you that that's not it. The teacher is not required to give you work if you're absent without talking to that teacher. That's no valid excuse. And even still, none of that applies because everything is online for you. With those due dates, I post them all in advance. So, Again, no one has an excuse because I told you what I was going to do in the first place. All right, let's talk about those ACT scores. Some of you guys have shown me your ACT, and I am blown away and proud of your beautiful ACT scores. I'm a man of my word, and I am going to do right by you. So if you scored between the 18 and the 19 on the ACT, math that is, I'm not worried about the composite because your senior year, that's when you worry more about that. Your junior year, it's just you taking it to prepare for the next step. You gotta maintain a 75% C to keep your exempt status. You must participate, your independent work must be great, and you have to maintain it. Don't miss too many days, and you are still responsible for the homework and the quiz. All right. And the reason why I do that because the 18 and 19 isn't all that impressive. It's good for your first time, but it's not all that. In addition to, you are exempt from our test, so there you are for that. If you score a 20 and above on the math ACT, you still gonna maintain a C, but your participation, your independent work must be great and maintained, and you can't miss many days. You have no test, you have no quiz, you have no homework. So what you do in the classroom is your grade. Now, before we get to IXL, I do want you to be fully aware that even with a high ACT score, you can still fail my class if you don't do what I am asking of you to do. IXLs. These skills range from the 6th grade to Algebra 2. Because there are so many of them, you still need to make the weekly progress, and it's a bulk of your grade. So last week, I pretty much gave y'all pretty much a lot of time to work on the IXL. Some of you guys have been crushing it. Many of you covering more than one topics. A good number of you have not. So when I record those IXLs in J Campus, and you not getting the score that you like, is what it is. You have to work. You have to get your stuff together. Make sure you make the good progress on that. So if I post you a weekly ISS to touch, you need to address those. Chromebooks. I will not have a cart of Chromebooks as often because now we are pretty much in our leap testing system. Leap testing. I don't have a cart of Chromebooks that I'm going to keep because we're gonna make sure that everyone tests. So I will be giving out more handouts during the classroom. Chromebooks are mainly used for homework. So you got a Chromebook, that means before you get to homework. If you don't have a Chromebook by this late of the year, kind of your problem. Because I've been working with you guys, begging and pleading for you guys to get Chromebooks from the jump. So do what you gotta do to get yourself situated. The only time that I would have a Chromebook card is only if I'm testing. Other than that, I won't have one. Binders this week, Wednesday and Thursday. You need to bring those binders because I'm looking for dividers. If you don't have dividers in there, you're going to lose points on that. Sheet protectors, you're going to lose a lot of points on that. And I'm looking for various handouts. So all the handouts that I gave to you, such as the statistics we did with heart rates, the empirical rule stuff that we have done. I need to see those there. Also, I'm going to provide you more handouts because this week my plan is for us to get organized about the portfolio. Your grades. Your grades consist of these items. Your IXLs. So when I put them in a weekly, I'm looking for to see what progress have you made to them. Your pair homework and other assignments that I post in Google Classroom. Classroom assignments, independent work, group work, whole work. So that means that when I say for the dome to the paper, I'm looking to see what can you do with that. Your group work, your whole work, I'm looking for all of that. And then your binders. I'm grading you on those things alone. Make sure you have those things ready. The remainder of the class, how this is going to work out the year. This is the last lesson I'm going to teach for this school year. After that, I'm just reviewing concepts that I taught you and what should have been mastered from previous math teachers because many of you, again, are going to advanced math class. You going. Feel you guys gonna be rolling with me in statistics. And I'm telling you now, for those who are trying to roll in my course, I'm looking for kids who have to do the work I actually had to really get to it. Although my work is class is much easier than Algebra 2, but you still have to be on top of your work. Like you have to bust. If you not want to like who don't like homework, you can't enroll with me. You just don't do it. Absence. Again, assignments are posted in advance, so you can't say, "Oh, I was absent." All the work that you needed for that time frame was posted. All right. Now, with that being said, let's talk about correlation. What does this mean? So, a correlation is a relationship between two variables. Correlated variables change together. Correlations are sometimes called trends. We are dealing with polynomials and non-polynomial trends, that is. Now, you want to see what I'm talking about, and it's going to look somewhat familiar. So, when we plot points, and you will plot them when they look like this, there's no correlation. So, when we're dealing with correlation, we want our points to form a perfect shape, albeit a perfect line shape, which you should identify this perfect line as a linear function, or it could look all like quadratic, or it could look like an exponential, but it has to have a perfect shape, and that's what we are looking for. It could be positive, it could be negative, but you're looking for a perfect relationship. It could be strong when it almost forms the shape, almost, or it could be weak when there's no shape being formed, or hardly a shape. All right, so here's an example of such. You have splash on the water park attendants, and you had a number of admission tickets sold and the high temperatures. So what can we conclude about this data? Pause the video and see what you can do. All right. And yes, the name of this plot that you see when you plot points is called a scatter point or scatter plot because you have lines out, dots all over. So the scatter plot shows a positive correlation because as daily high temperature increase, the number of admission tickets sold also increase. The correlation is strong because the data points form close to a straight line. So as long as you have said that as ticket, tickets increase, a high temperature increase, as long as you say something in those two lines, you will get credit for it. Because I want you to understand really as X increase, so does Y increase. So that's what I'm looking for. So you don't have to say it exactly like this, but I am looking for you to describe their relationship. All right. So let's talk about correlations and versus causation. So just because two variables are correlated doesn't necessarily mean that one variable causes the other. It could be a random coincidence that the variables are correlated. And sometimes when that happens, you do have to do more research on that. Maybe that's another reason for the correlation. For instance, maybe both quantities are influenced by another factor. When you do the homework, and when you have to explain, I am looking for this language. So be mindful of that. So here's an example. We want to identify correlation being just a relationship, causation being the cause and effect of one another. So, which one of these would be more of a cause or effect? Pause the video and let's find out. Alright, if, oh, I'm sorry, I went too fast. Oh well, we just gonna keep it moving. Alright, so in this situation, each of these relationships reflect a correlation, which relationship mostly likely reflect both correlations and causation, meaning that there's a relationship that's happening because of cause and effect. Pause the video and try it. Alright, if you say that burning more candles is associated with having a better smelling room, you are correct because that's cause and effect. Usually, when you burning candles, you will have a better smelling room, you know. Or you put more Febreze in there, your room will smell better. So cause and effect. All right. So we discussed how correlation is just a relationship, but it does not necessarily mean cause and effect. Let's talk more about the correlation. So you could use the correlation coefficient represented by a variable R to tell how strong a correlation between two variables is. Coefficients are numbers that range from -1 to 1. So if you have a coefficient of 1, positive 1, that's a perfect positive. If it's -1, it's a perfect negative. If it's 0, there's no correlation. So again, as I stated before, it's all about having a perfect unified shape. In some cases, it's going to be linear, and you're going to see some other cases. All right, now let's talk about regression. What is regression? Regression is Not only a linear relationship, in most cases it is, but not all the time. You have a approach to modeling the relationship between a dependent variable 1 and one or more independent variables denoted as x. A regression line equation of x and y are variables of interest in our data, with y the unknown or the dependent and x is the known or the independent value. Now, to determine a best line of regression or best line fit, you have to find the highest R value or the strongest correlation value for the functions. And there could be any functions that you will soon see. R values means how well the regression model fits the data, representing the proportional variance and the dependent value explained by the independent value. Alright, now you're about to see some examples of all these definitions. So here's the details. So when your correlation is a perfect, positive, and it could be negative too, but we always tend to deal with the positive. But if it's negative, that's okay too. If it's -1, it means that all variations in the y values is accounted for by the x values. If r squared or r is 83, that means that 83% of the variation in the y values are accounted for by the x. If r squared or r equals 0, that just means that there's no variation of y accounted for the x. So when you think of r squared r, those are those values that you're going to be looking for. So here's some example. If you're using regression models to predict house prices based on size, and if the R squared is 0.80, that means that 80% of the variation in the house prices can be explained by the size of the house. If you use another regression model to predict the number of lectures per day affecting the hours spent at the university per day, and if R squared becomes 0.895, that means that the number of lectures per day account for 89.5% of the variation in the hours of people spent at the university per day. So it pretty much makes sense, right? If you're struggling through this because of the speed of this, do not forget YouTube do give you the opportunity to slow it down. So, now it's going to start making sense to us. These are parent functions that we have been working with throughout the year. So, we work with all of these. Now, here's some little details that you need. So, these are our regression models right here. These are our regression models. So, when you're trying to determine which model to use, you got to think of the correlation value. So for linear, you're looking for just R. But for the rest of these, quadratic all the way down to exponential, you are looking for R squared. That's big R to the power of 2. And that's what you are looking for. So linear, you're only looking for R. For the rest of them, R squared. And again, R is the correlation that tells us about the strength of our relationship and determine if that's the correct model we should be using for our data. So here, I want you to go to Desmos. We're going to do this in class, and we're going to create ourselves a table. So you could take your time through this by pausing the video and keying in information as I go slow, or you can just move as quick as I'll go. All right. So after you create your tables, I want you to look at the shape, and it looks like a linear relationship. And then from there, I want you to go back to your table, go underneath your table, and because of the shape, well, hold up. This right here, this is just my axis, so don't worry about that. And remember the labels we did for the histogram? You'll do the same thing for regression, but right now you don't have to. So as I was saying, underneath your table, and because it's linear, type in your linear model. And because you're looking for R and not R squared, you realize that this is that the linear model is the best model to use. And because of that, it gives us our parameters, and our parameters is what we're going to use to create our equations. So if m is 1, that means it's just going to be x, because again, every x has a coefficient of 1 in front of it. So x plus 45, because b being y-intercept was 45 according to Desmos. All right. So the beautiful thing about Desmos is that you all you have to do is just go change the values of your table. So go back to your tables and input these values in. Now, if you notice, your R value is going to look different, so it's no longer linear. So now you're going to have to go through the list of models to look for your good R value or R square value if it's not linear. Because we looked at Desmos and it looked like it's a quadratic, we used the quadratic value and R squared was 1. So that means that when I look at my parameters, the parameters where you get your information from to create your equation, because b is 0, c is 0, therefore you get 10x squared as r squared equals 1. And again, how you notice this because of the shape that it forms. All right. Now there is some false information that you have to be careful about, because if you didn't change your model and you kept it as linear, it possibly gave you r squared to be 1. Possibly. But you know that that shouldn't happen, because for linear, you pay attention to r. So when y'all see that, pull me to the side, kind of talk to me, and so I could give you more clarification. Again, be careful with your models, because you put the wrong model in, you're going to think, oh, it's linear, but in this case, it's quadratic. Because if you look at it here, these 3 little dots form a good shape. And of course, this is a picture I just snipped out from Desmos. All right. I want you to try this one. And don't forget to change your model. So pause and try it. All right, welcome back. Did you get a graph that looks like this? And by now, you should recognize that as an exponential parent function. And did you get that information? I'm sorry, I went too fast again. But you can pause, look at your parameters, and create your equation from there. All right, what's the whole point of all of this? Regression analysis is the process of building a model of a relationship between variables in form of mathematical equations. The general purpose is to explain how one variable, the dependent variable, is systematically related to the values of one or more independent variables. All right, so I want you to pause this, read this, put this in decimals, and see what you can get out of it. And use your models. Pause the video and let's see what you got. Welcome back. Did you got a linear function? Did you look at your parameters and got the information and created this equation because you realized your R value of a linear function was the highest from all others? If you did, good. All right. Now, we are now getting into some hardcore situations where you have to not only just take the information out of decimals, now you have to explain your pieces all together. So pause the video and let's just try it. All right, welcome back. Did you get these to be as a quadratic because the R square value was at its highest? All right, I want you to now try this one. Now, I already told you it's exponential regression, so I told you that much. So just create your model from the exponential model. And when you did that, did you get this? Good job. If you did. All right. Now, since we know how to go to decimals and, you know, create regression models, now our time is for us to analyze the regressions. So, you have an example here. The owner of a bicycle store wonders if the employees who take the longest lunch break also make the fewest bicycle sales. One day he notes the length of each salesperson's lunch breaks in minutes, as well as the number of bicycles he or she sold that day. So here's the model. So we can interpret this because it's linear and we know the unique characteristic as slope is that if a person spends one additional lunch minute, our equation predicts he or she will sell fewer bicycles per day. Again, I was looking for the rates. And I knew it was the rate because it being a linear function, and linear functions are always associated with the word slope, or a proportion, or a rate of change. All right. So now, what I want you to do next is to read this information and model and try and follow the directions and explain it the best you can. Right. This is our model. Now it's telling us to plug in some values. And we plug in 90 because it's 90 is our max. Our max is our x value. And I'm in 69. So when you are working on these problems, you have to state our model is this situation, which tells us that the mean temperature will be 69 degrees when our temperature maximum is at 90. So there you are. Now, I want you to pause the video and work this out and see, can you explain it the best you can. All right, welcome back. Did you get the model as that, being an exponential? Did you explain it? It is predicted that the predicted number of a single cell organism to the nearest whole number at the end of 18 hours is 341. If you got this, or you said something similar to this, nicely done. So, y'all, how do regression self have the precise definition of mathematics? We did measure because of the correlation value. We did make an inference based on this value of R, and we create those and we model patterns arising in the environment. So that is how we satisfy the precise definition of mathematics in this lesson. All right, so this is what I want you to do. I want you to pause. I want you to try these incoming problems on your own. And yes, a good bulk of this lesson did come from IXL, but I am going to take away those statistics ISLs because the IXL stuff that I've been wanting you to do, that's going to be mainly assigned to this. That's not for you guys. I gotta focus on the math because that's your teacher who you be dealing with. It's all math and not much statistics. All right. So here, I want you to go through your list and identify the model, the best model from those parent functions that I gave you. You're going to do the same thing here.